So I want to do another example. Let's solve the separable equation y prime is equal to 6x squared y. So I want to solve y prime is 6x squared y. So here I want to find all the functions whose derivative is equal to themselves times 6x squared. This would be basically the same strategy as before. We're going to write dy dx for y prime. We're going to separate variables. So again, separating variables, this method of separating variables is really useful for when you want to find derivatives of this form. Okay, so here you just get all the y's on one side, keep the x's on the other side, integrate both sides, and then try and solve for y. That's basically the strategy. So here we're going to get the y's on one side. That gives us 1 over y dy is equal to 6x squared dx, and then integrate both sides. That's our entire strategy. And so if we integrate both sides, we're going to end up with the natural log of the absolute value of y is equal to, let's see, we're going to have 6x cubed over 3, so 2x cubed plus c. And let's see, this means that we're going to be able to solve for, if we exponentiate both sides, the absolute value of y is e to the 2x cubed plus c. So we can do both of the tricks that we did in the previous example. We can drop the absolute value because if we have an exponential, we know that that's got to be positive. And let's see, we have e to the 2x cubed times e to the c, or c times e to the 2x cubed. And it turns out that's going to be the that's going to be all of the functions whose, it's going to be all the functions satisfying this differential equation y prime equals 6x squared.